Right, so good morning everybody and welcome to this Tech Thursday session brought to you by Socomec as we discuss energy storage systems. My name is Markus, Hugo, and I manage energy storage opportunities for Socomec in the UK, and I have with me today Dr. Richard Govier, who is our Technical Director for the UK.
Good morning everyone, and thank you for taking the time to join us this morning. If you have any questions during the presentation, I did put it in the chat earlier, please type them in and we'll try and answer them at the end of the presentation. If we do run out of time, which is usually the case, then we'll get back to you after we finish. Over to you, Markus.
Excellent, thank you, Richard. So looking at the agenda for this morning, we'll take a quick look at the global energy market and where it's heading, then on to understanding the energy transition, key drivers for the energy storage market, some applications for energy storage, onto our product offering, our Census energy storage system, and then finally onto some case studies. Okay, before we get into the presentation, just a quick introduction on Socomec, who we are, for those of you who do not know. We're a privately owned company owned by the same family for the past 100 years. And as you may have seen on the opening slide, we celebrated our 100th year anniversary this year. Our turnover for 2021 was in the region of 604 million euros. And the standout number there is that 10% of that turnover gets put back into the company for research and development. We have 6 international production sites. Our head office is in France. We then have our main production facilities in France and Italy. And we also have sub-assembly plants in China, USA, India, and Tunisia. We have representation across all continents, so pretty easy to get hold of us. And we also have 5 main business units operating within the company. Run through these very quickly. These are power switching, power monitoring, power conversion, energy storage, which is obviously the topic of today's discussion, and then expert services, responsible for looking after all the products supplied and manufactured by Socomec. Okay, so getting back to the main presentation and a look at the global energy market mix. This information is courtesy of BP. It is available on their website. And what we're looking at here is, if you look at the graph on the right-hand side, with regards to fossil fuels, you can see that firstly, oil, which is represented in green, it has been declining over the years, but it still holds the majority of the share mix. This is followed by coal in grey and then natural gases in red.
I think what's key there, Markus, you can see on the graph the dip, which was obviously the COVID years.
Over there. Yeah.
Absolutely. But you can see the red, which is a natural gas, is still a high percentage of the world consumption. And obviously for us in Europe at the moment, that's a real concern because in 2021, 40% of our gas was delivered from Russia.
Yeah, absolutely. So continuing, we have hydroelectricity in blue, which remains relatively stable. You then can see that renewables, which is your wind, solar and other biogas forms of energy, has actually overtaken nuclear power generation, and the renewable energy market is set to reach $1.9 trillion by 2030, and this is up from approximately $880 billion in 2020. Of course, as Richard has mentioned, this energy mix could change significantly with all that's happening in the world today. So continuing with the energy mix and looking at the mix across all regions, you can see oil still shown in green is most common in America, Europe and Africa, and then natural gases shown in red is most common in, or most dominant in the Commonwealth independent states and Middle East.
And obviously, just for people who might not realise, CIS is the old Russian Federation, yes. So it's basically Russia.
Yeah, old Russia. And then lastly, coal, which is shown here in grey, is most dominant in Asia Pacific. So it's quite clear to see that fossil fuels are still dominating the market across all regions. It brings us onto energy transition. What does that mean for us all? So basically it refers to the global energy sector shift from fossil fuels, this is your oil, gas and coal, to renewable source of energy, being solar and wind. This is in an effort to reduce our global carbon footprint.
And obviously the 2 buzzwords that we're all familiar with, net zero, carbon neutral, that's exactly where that's sitting.
Correct, exactly. So reducing our global carbon footprint, that plays a big role in sustainability globally.
And I think on that slide, Markus, what Socomec is very proud of, we hold gold for EcoVadis, which is a sustainability rating.
Yeah.
And that actually puts us in the top 5% of companies who've been registered with EcoVadis. So it's a big area for Socomec.
Yeah. And also, just to add on to that, companies are actually making selection of their partners based on their sustainability ratings.
Yeah.
Okay, so looking at the key drivers for the energy transition. First and foremost, we really do need to move away from fossil fuels. So by this, we mean electrification of previously fossil fuel technologies. A prime example of this is internal combustion engines, replacing internal combustion engine vehicles with EV vehicles.
And obviously, the second one there, gas emissions, reduction of greenhouse gases. At the moment, we heat our houses in the UK on natural gas, which obviously, with everything that's going on that we've spoken about, is an area we have to move away from.
Yeah, correct. Another key driver there is also integration of renewable energy sources, because if we're not going to be getting our energy from the fossil fuels, we need to be getting it from somewhere else. Something else that's not on this presentation or this slide is your energy efficiency, the way we use energy. That's also a key driver there. Okay, so key drivers for energy storage. Basically, the energy storage plays a vital role in your energy transition. We'll take a look at these. REN integration, we'll take a look at that in the next couple of slides. Energy cost savings, I don't need to tell anybody about this. Energy prices are high, we all know that. Grid reinforcement, there are periods where your grid may not be sufficient for your demand, so limits on your grid capacity. Energy storage can help with that. Grid resilience, there's also talk about energy uncertainty, so your energy storage system acting as a secondary source of power. And then finally, CO2 emissions. Again, we've spoken about this.
Obviously, on this, Markus, it also has to be financially viable. People are not going to install energy storage just because it's a nice thing to have. Yeah. There has to be a return on investment.
Yes. So absolutely, the key there is to actually optimize the use of your energy storage system by stacking various applications in order to multiply your revenues and improve on your return on investment.
Yeah.
Okay. So getting back to renewable integration, we all know that renewable energy is not constant. It's intermittent production of energy, and it's often time shifted from demand. So as you can see in this diagram, typically your PV generation period there peaks between 7 a.m. and 7 p.m. in the evening, and then your energy demand periods falls outside of this window. So early morning, 7 a.m. when people are getting ready for work, as well as when the majority of people are coming back in the evenings, you have your peak demand periods there.
And obviously we've seen in the news recently, Markus, the scaremongering about blackouts potential this year because obviously the issue of gas and the current conflict in Ukraine.
Yeah.
That peak is exactly where we'll be looking at. The solar is not producing when we actually need the energy.
Exactly, yes. Other issues encountered is that the distribution network architecture is not suitable for massive renewable integration. So what this means is you pick up transients on your transient constraints with regards to voltage, current and frequency. So by basically associating your renewable integration with energy storage systems, we can remove these constraints and bring added benefits such as energy efficiency, energy availability, and other grid services. Okay, moving on to energy storage applications. We'll take a quick look at the energy storage market for the UK. The top graph over here shows installations by megawatts, and you can see in 2022 we had a massive increase in front of meter applications. This is a forecast for 2030. We'll see that you can have a look there that the commercial and industrial market as well as residential markets have remained low. But what is interesting to note, we can see here the revenues generated by the installations are really tracking the installation graph above, so it is a profitable sort of business.
And obviously, just to recap there, Markus, so that's installations per year, so you can see the installations are continuing right up to 2030, which is where that graph is showing.
Yeah, exactly.
Yeah.
And again, this is forecasted and it could change, especially with what's happening in the market nowadays.
Yeah.
Okay, so energy storage services. As you can see, energy storage systems can offer multiple services across all sort of options there. What we're going to look at is the ones more specific for the UK market, which is financial savings, money saving, and then also EV services, so EV charging.
Yeah, just to note there, Markus, the off-grid services, the isolated microgrids, this is an area Socomec have been deploying in for quite a number of years across the French islands, mainland Africa, where there is no grid or very lack of grid support. And deploying energy storage to provide the microgrid, and it's an area that we know very, very well.
Yeah. So if you do need any assistance in those areas, please do contact us. We'll be happy to help. Okay, so on to peak shaving, money saving. What we have here, it's not something new, it's not a new concept. It's been around for many years, and this is basically where we make use of a secondary power source to carry you through your peak demand periods. Looking at this graph over here, this picture, you've got a limit which could be normally set by your energy provider, and typically exceeding this limit would result in energy penalties. So having a look at the limit there, you've got your consumption happening, and your consumption falling over and above that limit is taken out, the energy is actually taken out of the batteries rather than from the grid. Next, looking at self-consumption. So self-consumption, this is where you're generating power on site to make use of on site, and as you can see here, typically again you over-generating, well, you have excess generation of power there, and inside the red square, that power can then be stored, your excess generation can be stored inside your energy storage system battery, and then could be shifted for use at a later stage when your generation is not producing as much.
And obviously that could be used on price arbitrage as well, whereby you're going to charge the batteries when the energy from the grid is at low cost, so overnight, and then discharge that into your system, into your load when energy is high, so during the day on the peak times. And
similarly, that would also apply for load shifting, so shifting your load from one period of time to the other. Okay, onto the energy storage product itself. We've spoken a lot about storage, taking a look at the basic principle operation of an energy storage system. This is a simplified diagram over here. We've got two modes of operation. So the first mode of operation shown by the green arrows. This is when we're absorbing energy into the battery. So we're taking an AC voltage, converting it through the power converter itself, and then storing it inside the battery for later use. When that time comes, when the second mode of operation, we're discharging or making use of the stored energy in the battery, we again discharge it, so via the red arrows, the flow of electricity, DC voltage through your converter, converting it to an AC source, back onto the grid, or for use onto your site.
Obviously the key point there as well is that obviously this is a regulated area. To connect to the grid you have to manage the grid codes, which in the UK is G99, so we have to be compliant with that.
Yes, absolutely. Safety is key. Okay, so this is our Sunsys HESL energy storage system. As we've discussed in the previous slide, we have two basic components, which is your power converter, shown here on the right, and then in this instance we have two battery cabinets connected to the system. Looking at it in more detail, so this is a modular design, making it very easy to design and specify for a client or for a site. Looking at number one here, your C cab. Again, this is your power converter cabinet, and it consists of 50 kilowatt power modules, and these power modules can be slotted into the cabinet. 6 of these power modules in total in one single cabinet, making up 300 kilowatts of power. That cabinet also holds the automation box, so the brain of the system. And then we move on to number 2, the B cab. This is our battery cabinet. We make use of lithium iron phosphate battery technology, one of the safest lithium ion chemistries available on the market today. So inside this cabinet we have the battery modules themselves. We also have a fire safety detection and suppression system, as well as a cooling closed loop liquid cooling system to maintain the temperature within the battery or the battery cells. Thirdly, we've got the DC cab. So this is your DC distribution cabinet. It's really only required if you add in more than 6 battery cabinets onto one DC cab, C cab, sorry. And then lastly, we have the AC cab. This is a flexible cabinet. It's designed to order, so engineered site specific. and is really used for AC distribution, multi-source paralleling, and islanding functions of the energy storage system.
So just to recap on that, Marcus, so the C cabinet is where the batteries are, the converters. You can have 6 converters, which gives you 300 kilowatts.
Yes. You
can then put them in parallel?
You can parallel the C cab, so for added capacity. But if you're going into megawatts, we also have the Sunsys XXL modular system, which is a 1 megawatt system that can also be paralleled, 1 to 1.5 megawatt of power.
And obviously the other thing is these are native outdoor cabinets. They can go out as they are. They're IP55 double skin cabinets. So
Absolutely.
You could just put them on the plinth and away to go.
As it is there, can be installed outdoors and off you go.
Okay, good.
Okay, getting to the management and control of the system. There are 4 platforms. So your basic platform is your power management system, and that takes care of day-to-day day-to-day operation of the energy storage system. We then have a more advanced feature of the power management system for secondary services, so self-consumption and peak shaving. And then we go off into the cloud for your advanced energy management system, which facilitates supervision, remote supervision and operation. And also it stores different values, so power, energy, consumption, etc. Lastly, we have the advanced energy management system. This ties in with weather forecast systems, so you can enhance or optimize the use of your energy storage system with your renewable integration.
I think just as fair to say there, Marcus, the 2 higher ones there, the EMS, they are very site and project specific, and obviously would be specified as part of the original project specification.
Yes. Yeah. So careful consideration must be taken when designing and looking at your management of the system itself.
Yeah.
Okay, so moving on to case studies. This was for a very well-known global logistics company operating in London. They basically had over 170 vehicles in their fleet, and they made a decision in 2019 to replace these motors with EV vehicles. Basically what they did was during the conversion process, they basically found out that they had consumption peaks exceeding the grid limit. And what this did was put obviously a lot of demand onto the grid, which they didn't have available. And to top it off, they also had PV installed on site. And as you can see here, the PV production was not covering all the peak demands from the chargers. The solution was they employed the services of a specialist engineering company, energy management company, and along with our energy storage system, their PV installation and smart charging technology, we were able to offer them the power that they needed for their charging points, and we were well below the grid limit connection.
Yeah, so just on that, Marcus, I was involved in that project from the start. As you say, it's a well-known facilities company or a courier company. There was not an option to reinforce the grid. It was going to take 24 months with some silly amount of money involved. Yeah. And what they deployed was some very intelligent chargers as well, so that they knew where the vehicles were going the next day, so they could have the vehicle charged to 100% if it was on a long run. If it was a shorter run and they knew that 50% of the charge would be sufficient, they could manage it that way, and it worked really well.
Yeah. So, like you say, energy optimization there.
Absolutely, yeah.
Moving on to the second case study. This was for in Spain. It's basically a company that installs charge point installation company. They picked up similar problems. Again, the peak demands were outside of their grid connection limit, and they employed our services to help them with their consumption peak management. And we basically ended up installing our latest Sunsys HSL product at various points around Spain.
I think it's fair to say, Marcus, this is an area we're seeing a lot of interest in the UK, with the move to EV vehicles, and obviously the fast chargers, because people don't want to be parked up for an hour to charge their vehicle. Yeah. And the grid is just not there to support it.
Exactly. In some instances, these rapid chargers are 400 kilowatts per charger. So you can imagine the amount of energy demand on the grid if you have a couple of these or many of these installed at the forecourts.
Yeah.
Okay. All right, so before we complete or conclude our presentation, we're going to have a quick look at an installation of one of our Suncess HSL systems. So it should be coming up onto the screen. Okay, so we have been designing energy storage systems for over 10 years, and we have hundreds of these installations around the world. Our latest Suncess energy storage system is easy to configure, and for any application, thanks to its modular design and standard cabinets. This also makes for rapid deployment possible. These are as I mentioned before, the battery technology is one of the safest available on the market, and these systems can really be installed anywhere.
Yeah, so I think the video that's being shown now is actually a deployment, is actually from one of our French sites. Apologies, the commentary is in France, but you might get the gist of it. You can see here the concrete plinth has been prepared beforehand, and you can see there the cabinets now are being delivered and bolted. They obviously have to be bolted down, so they have to be tethered to the floor because they are, heavy with the lithium-ion batteries, and especially if it's fully populated with 300 kilowatts. It's a heavy cabinet.
It is. So basically what they're busy doing there is they're doing final connections on the power side. They're making sure that the torquing is all correct.
And obviously what's key here is that this is all configured at the Socomec factory. So I'd like to say plug and play. It's probably people will shout at me saying that. But it will have been configured at the factory. It will have been fully tested at the factory. You are going to deploy a concrete plinth, and then obviously manage it installation on site. You can see they're bolting the cabinet to the ground.
Yeah. They're doing final control connections, so your connectivity between the battery management system and the actual power converter cabinet. These cables are all supplied by Socomec. The trunking between the battery cabinet and the converter cabinet is also supplied by Socomec, and it's a weatherproof sort of housing.
And obviously at the start of this presentation, expert services, Socomec employed engineers, we'll be there to manage this installation, configure it, and obviously maintain it through its life cycle. It's a Socomec solution.
Correct. So with that, we've come to the end of our presentation. I hope that you enjoyed it.
Yeah, so there's just a few questions here, Markus. Some have been emailed in, they're not on the chat. People have emailed me directly, obviously they've got my email address. The first one here, could you just clarify front and behind meter, exactly what we mean by that?
Yes, certainly. So front of meter application, this really refers to sort of your energy providers, your distribution network operators, as well as your transmission system operators. So anything that's happening in the generation, transmission and distribution sector. Behind the meter application, this really refers to your consumers. So this will be commercial and industrial and residential.
Another one here, again via email. Can energy storage be used to replace diesel generators?
Absolutely. As you know, Richard, a lot of the times, nowadays diesel generators can be seen as dirty power, and regulations in buildings may not cover that for generators. So using a battery energy storage system, we can overcome some of those challenges and provide sufficient power.
Okay. One here on the AC coupling cabinet. Is that supplied by Socomec? Is that part of the solution, it's asking?
Yes, that is actually designed and supplied by Socomec in-house.
Okay, so and the same native outdoor IP55 double skin, exactly the same.
So we use exactly the same cabinet, we just design or engineer the internal components.
One on the chat here, and it's to do with cycling of the batteries. And the life cycle of lithium-ion batteries and how many times they can be cycled as part of their life cycle.
Life cycle.
Well, typically, the lithium-ion batteries at the moment we're looking at 10 to 15 years plus. Obviously, that changes as the technology changes and the development takes place. Typically, we're looking at about 3,000 cycles. that's the number I've got. But
Yeah.
Gordon, we'll come back to you as a specific question you've asked there. We'll get the specific data from the manufacturers and get back to you on that.
Yeah. It's important to note that your warranty is applicable for a single charge and discharge during the day, full single charge and discharge. But obviously, if you are using the energy storage system for multiple discharges and charges, the warranty on the battery is affected.
Okay. There's no more questions. As Markus said, if you have any questions, please email us at the end of the presentation, and we'll be more than happy to get back to you. We will come back to you, Gordon, on your specific question on cycles.
Yeah. With that, thank you so much. I do hope that you guys enjoyed the presentation. And again, if you do need to contact us, the email address is on the screen, info.uk@socomec.com, and we'll be happy to assist you. Thank you so much.